What I'm going to demonstrate today is essentially a product that Intrepid made in cooperation with Analog Devices, or ADI, for what they call their WBMS solution. WBMS means Wireless Battery Management System. And so ADI's got lots of wonderful information to tell you why you should be using wireless BMS versus a traditional wired BMS. But basically, the idea is that a wired BMS means that you are wiring up, even if you have, like, say, nodes or modules that are inside the battery pack. Even if you have those, you still have to wire them up to some battery management module. Okay, so you'll have some BMS module, and everybody has an acronym for that. And the problem is that that's copper. And copper costs money. Copper is additional weight. To wire that, you usually have to use human beings. It's not easy to automate if you can at all. So there's more time and labor to put together the battery pack, which is a big concern for production. And for design, okay, so apart from all those other considerations, design, you have connections, that's connectors, and those are failure modes. You don't want those in battery packs. You want to minimize those as much as you can, because everybody's already heard the horror stories about if the battery pack goes bad, what do you do? Well, it's not fun. And of course, then there's the secondary uses of partially bad battery packs, that kind of stuff that we talk about in other uses. But of course, having that wiring is going to increase your development effort. And you even take up a little bit of volume inside the battery pack. If you have some room in the battery pack, what do you want to put in there? Battery. That's what you want. The more battery you can put in there, the longer you're going to go and the more competitive you are. So this is actually straight from Analog Devices website, and it really shows what the possibilities are. Essentially, on the left, you see a wired battery pack, and it talks about what resources are used in a conventional wired battery pack. So you're looking at 12 different modules in this case, but now there's 24 harnesses, 48 pairs of connectors, and you have 12 CMCs, essentially the node modules, okay? So they're watching the cells that are in each of those sections, if you will. Whereas on the right-hand side, you look and it's like, it's all wireless. So you've eliminated the harnesses, the connectors. You basically have modules that are, you have wireless modules that are on each one of the nodes or portions of the battery pack. Those are talking back to the wireless manager. So basically that's where your BMS would be in wired, and of course we call it a WBMS for ADI. So the thing is, if you're involved in BMS, you will be involved in wireless BMS. And then probably as you go forward in trying to do your testing and as well as your production, it makes a lot of sense to look at the product that Intrepid has developed with ADI, the RAD-WBMS, and I'll tell you why a little bit as we go along. So usually, and especially this year, we've had a lot of companies come to us, a lot of OEMs come to us, or ADI asks us to come along because they're trying to figure out, okay, where do I start? Okay, of course you can get a developer kit, and that developer kit will have a node simulator in there and a battery simulator in there, and you can get a manager simulator, and that's all great if you're a developer trying to knock things around and you get a basic prototype going on a bench. But the moment you want to start to really move towards the testing, the development, the PVDV, end-of-line testers, you need a lot more than what a developer board may give to you, okay? And so one of the things is, you might say, well, I really would like to have an API that I can just talk to this device so I can get the information I need from the nodes or from the battery pack, and then send that on to some other piece of software. Another thing might be, you just need a GUI because you have a pretty good idea of what you want. But what happens when you just want to do a simple test, or maybe something more complex, honestly? If you want to do a test you just need a piece of software so you can proceed with that test. Maybe do some integrations, maybe through Skippy or other means to integrate it with a test that you have in mind, whether that's production or just a bench test. And the third one is where people almost always go at the very beginning in the initial talks. Even if I tell them they will need this and they say, no, we don't need it that way. I literally been in meetings where they tell me, no, we don't want it that way. And in the end, they say, you know, it would be great if you just got the information out from the nodes and put it on CAN for me, and I can put that into my existing test system. So, so now with all that said, that first solution, sure, you can get a bunch of ADI developer tools, okay? Now, you may not be as persuasive as John Wick here and just say, I want lots of dev boards, because dev boards are made for development, initial testing. They're not made to like order 4,000 of them and put them out in all your factories throughout the world for doing a production test, okay? So that's one avenue that once you investigate it, you find out very quickly you cannot get enough of them. In fact, Intrepid has troubles getting dev boards sometimes because they need to give them to the customer that are trying to evaluate this technology. And the technology is very hot, so you see a lot of people asking all at once trying to get this. Because at this point, if I remember right, ADI is the only chip maker at this moment that has a production version ready to go already. And it already has it in production vehicles right now. Another less common solution is to actually take your manager that you already are in the middle of developing, and I'm talking about not done at all, but I literally have like a prototype of some sort. Maybe I can make 20 or 30 of those prototypes to do my testing. And essentially, instead of using some type of device that can be the manager, literally use the manager inside of the ECU so that I can talk to the nodes and get information out. But the problem is, well, there's several really, but the first problem is every time you attempt to do a software update, that means you got to update the software in all of those prototype ECUs that you have out there doing the manager's job. And that's not very convenient. So I've talked to customers where every time that happens, they throw somebody onto a plane, fly them halfway across the world, and they spend 2 days or sometimes more updating all of the necessary ECUs. And that's at a very early stage, by the way. I could never imagine if you were at full production and you had some kind of update that had to happen, and then you send them to all the plants where these things are being made. That could be tricky, to say the least. Not to mention, you have to think about, of course, the production is going to happen at the battery maker, and then they're going to hand it off to the assembly plant. Well, they've got to check those too. So they got to replicate all the end-of-line tests that are happening at the supplier. They have to be replicated at that OEM. Again, of course, there's just getting the number of ECUs you need, right? If you're getting prototypes, number one, you know they're expensive, very expensive. And number two, just getting enough of them is difficult. And I could spend 15 minutes telling you about what my customers have gone through just to get extra ECUs that are in development because everybody needs them. It's kind of like having a bench that's a static bench. And imagine just not too long ago when we didn't like use Teams or Zoom or remote desktop to get into things, and everybody's competing for that one bench. You know, just because you have Teams or remote desktop, if that one bench is in one spot, sure, you can use it throughout the world, but still there's competition for the bench. So that's another possible solution. So what's this RAD-WBMS product anyway? You know, how is this going to help me solve these problems? So essentially, the RAD-WBMS is an ADI dual manager in a box. It has its own API. It's supported by Intrepid. You can integrate it into your testing tools. You can integrate it into a production test stand, do functional test, end-of-line test, PVDB. And so basically everything from even the prototyping on the bench all the way to and including production you can do with the RAD-WBMS, okay? And PS, it of course runs with Vehicle Spy, so you can even make your own GUI, and you don't have to do anything else, just put together your GUI. You can do some of the basic scripting, it's all built in. So who is this RAD-WBMS for? You've probably gotten a hint already. I got a little bit too much text on here, but I'll go through it. For engineering, of course, for bench testing. Yeah, absolutely good use for it. For the battery lab, being able to do things like cell balancing, environmental testing, being able to do the various testing that you do on a pack in a battery lab. And of course, for manufacturing, being able to check both at the module level and at the pack level, testing and verifying that the pack indeed does work, okay? So it takes care of all those issues for the OEM. For the tier one, very much the same types of things. In fact, I probably should have moved some of the details from the tier one up to the OEM because things like pairing, when you put a battery module into a pack, one of the things you think of is like, well, how do I like pair that so that it's like part of the vehicle, if you will? And we'll talk a little bit about that because there is definitely security that's involved in here. As soon as people hear, by the way, they hear wireless, oh my gosh, anybody can hack it. Well, keep in mind, all the components are ultimately inside the battery pack that is in a big metal box. So wireless is actually happening inside the box. It's not like you drive up and like, hey, I can see you got, 24 managers inside, or you got 24 nodes inside this box. It's not like that. And furthermore, there's additional security concerns as well to pair it in a production sense to the vehicle, much like most ECUs are paired to a particular vehicle, a particular VIN. So tier ones, again, engineering bench tests and the PVDV managers, and doing the end-of-line tests, the functional tests that you need along the way as you are in fact manufacturing. And then you can think of things like, well, once this battery pack's out in the field, how do I service it, right? Well, if anything, you think, well, I take it to the dealership and they say the battery pack's bad, and hopefully they cover under warranty. We're all begging and hoping for that instead of paying, $20,000 to swap out a battery pack or more. What do you do when you get that big battery? You want to diagnose it. You want to basically reuse it. You don't want to throw it away. You can diagnose what exactly is wrong with the various nodes inside the battery pack with a RAD-WBMS. You can, of course, decommission, find out which ones are the bad nodes, pull those out, use the remaining nodes, and reuse them in some other application. So, for instance, stored energy like a windmill. Okay, so there's a lot of thought about what do you do with these batteries when you're done. You don't want to just throw them away. And then, of course, continuous monitoring. I'll get into some of the details now. Essentially, the idea behind the chipset or the WBMS is that it has a dual manager inside, meaning that I could actually operate with two completely different sets of nodes. Okay. Why is that valuable? It essentially doubles the number of nodes I can put into a single system. Okay. There are also two ISO SPI channels. The ISO SPI is essentially an ADI proprietary version of a SPI, but basically we'll get to the why would you need the wired stuff in the first place if this is all wireless. We'll get to that in a little bit, but it's important. I have two CAN-FD channels on here, which are really great for doing gateways to CAN. And then there is 100 base TX, so basically 100 megabit Ethernet connection, which you can use to connect to your computer or use APIs. And then, of course, there's a membrane. Any products you've ever seen from Intrepid, you see nice, cool, multicolored LEDs. We like those too, and we put them on all our products. So to be able to tell the statuses of the networks, we have that all at. So there's two different ways to connect up to a WBMS network. The first one is to use what we call internal manager, okay, which is basically to use the wireless to connect up to the nodes. So in that case, the WBMS is acting as the manager in the WBMS system, and it will gather all the information It's also used to flash in configurations into the nodes, and you can flash in a configuration into it as well, okay? So that they match. Anything that is told to you by ADI that you can do with WBMS, you can do with a RAD-WBMS product. So that covers that pretty much. The other way is external management. What this means is don't use wireless at all. You use the ISO-SPI lines to connect wired to the actual manager. So you can do all the same tasks, but instead of the WBMS being the manager, we are simply a conduit for ISO-SPI to talk to the actual manager, which would be in your, say, battery pack, or it could be part of a test system that you happen to have. So you can actually do that and actually connect up to a dual manager. So you can do that. You can actually talk on two separate ISO-SPI lines to two separate single managers. That's a new feature that's just come out. And also be able to talk to ECUs that happen to be using the ISO-SPI line. So if you have a situation where there's, basically the coordinator, if you will, which is the BMS module, you might have some other modules that might in effect be followers, okay? And we'll actually be talking back and forth an ISO-SPI. And they're not actually directly part of the WBMS system, but they're part of the battery pack or part of that subsystem. And therefore, you can talk to those wired as well, okay? If you're using internal managers, pretty straightforward. You have all of your nodes, if you will. These are the portions of the battery pack. So this would have basically up to 24 of those in a particular configuration. And then the network that ADI is using is a 2.4 gigahertz. Essentially, it's Wi-Fi, or Wi-Fi. Yes, it's Wi-Fi. It's a special band of that Wi-Fi, but essentially they use a proprietary protocol to talk between the nodes and the manager. And the WBMS sits in the middle as the manager, if you will. And then you have a couple of different options. One, you can actually do a gateway on CAN and take that data out to your bench, to your tester, to some other ECU. The other option is use USB or Ethernet and go right to vehicle SPI. So then you can write your own GUI inside of vehicle SPI, use all the tools that you know and love inside the vehicle SPI. Now the external manager, if you look at the left side of RAD-WBMS, you've got that ISO-SPI connector, the little iGrid, I think it's a 16-pin connector. That basically has two ISO-SPI lines on it. And then you can connect those to the actual WBMS ECU. So this would be what either you as a tier one or you as an OEM are making or using in your actual battery pack. And we can talk ISO-SPI with that, again, talking wireless to the nodes, but we are not taking the place of the WBMS ECU. We are talking directly to it. And there are definitely applications for that. And in both cases, we can use the full library of commands that are provided in WBMS. And then again, you can either do a gateway or do USB or Ethernet to vehicle SPI or to other software for that matter. Before I go any farther, any questions? All right, no questions. I am an awesome teacher. And I've got 4 minutes to go. I didn't realize I dawdled too much. That's okay. We were actually pretty close to the end, believe it or not. So one thing that is we just got proven out at one customer, and that is in order to do a CAN gateway, which is really pretty much the first application that you're going to run into if you're doing WBMS, is just get the data that I have on WBMS, get it out to CAN. You can simply go to the Neobuy Explorer, and if you click on the WBMS network settings, you just select your output network. If you select none, there's no gateway. If you select either the Ethernet or the dual wire 1 or 2, you get an automatic gateway to CAN. All you got to do is send a configuration to the device, and then the device will start spitting out all that information on the can for you. And that's really convenient because, like I said, almost every single customer meeting I've ever been at, the first thing they're thinking of is just getting it out to CAN, especially if they've had wired BMS before and they have a system that's doing CAN. They would just like to use the same system with some modifications so it saves some time. And that's just really just a repeat of the slide before. It just shows the direct connection to CAN. By the way, one thing to notice here, you see there's no computer there. It's actually all run in the firmware of the WBMS. So you can run this without a computer at all, literally as a gateway standalone. Okay. You can run a computer with it if you'd like, though. You can do it at the same time, which is kind of like what we do with our products. We like to allow you to do things like make it a pass-through, and we want to do, XCP, and we basically name it, and we try to do it all at the same time with our single interface. We've already talked about that. That was actually what I just talked about, is being able to run Vehicle Spy at the same time as a gateway. Now for API, we do have a full API, and it actually uses the existing API that you know and love. So you're able to use that and integrate that into your own test tools. So you don't need Vehicle Spy. You don't have to run Gateway if you don't want to, but it's your option, and you can still use the APIs at the same time. The special API commands, which I cannot go into because they are IP of analog devices, those are all supported through methods that are actually in our public API. For more details, you're gonna have to talk to me, and then I talk to ADI, and I verify we all have NDAs together. But I can talk about that in a lot more detail in a closed setting once we verify everything. So that API, by the way, that's free. You don't have to pay for Vehicle Spy if you're doing API, and sometimes that's a big concern for, say, production factory stuff. So essentially, this is really something that's just really a repeat, except now there's no Vehicle Spy involved. It's the API in some computer somewhere. And of course, you can build your own test inside of Vehicle Spy. That's what you see in the demo that we have out front. Is essentially a quick demonstration of what you can do. There's graphical panels, there's function blocks, which are part of our scripting. Of course, there's a C code interface and a runtime license that you could run on a computer in, say, a production environment. That's a lot lower cost license, but also only allows you to run it. You cannot edit it or look at the code, which is really nice for production, where you just need somebody to go in and I need you, or I need the machine to press the button, do the test, give me a go, no go, tell me what to do with that particular node or tag. And I've got a couple of different slides in here, which I'm happy to share at the end of this. You'll all get an email if you've given us your email address. We'll email out all these slides as well. So basically being able to make it visual, you see this, in fact, this exact same output is on our WBMS demo outside. And I talked about the VS3 EXE. That's essentially just simply a way to, run Vehicle Spy VS3 setups, but not have to pay for the full license, like paying for an enterprise or pro license. Okay. And I'm more than happy to show you the demo that we have set up outside.